Sometimes you buy solutions of acid or bases, they are very concentrated, and you would like to reduce the concentration to a given amount. Suppose you have a solution of hydrochloric acid, which is 12 molar, and you want to dilute this to a 0.5 molar, going from 12 mole per liter to 0.5 mole per liter. So we want to dilute a given amount of the concentrated acid, the 12 molar acid, and dilute it to, let's say, 100 ml of 0.5 mole per liter. So that's the type of problem that you will be dealing in a lab if you are doing a dilution. So one assumption that we should make in dilution is very simply the fact that in dilution, the amount of the material which is dissolved in water is not changing. In other words, as I said before, I give you an example. Suppose you have a cup of coffee, you add some water to it. Is it fair to say the amount of the caffeine is not changing? We just change the volume, we change the concentration, but the amount of caffeine is not changing. Let me shut my video so you're not using as much internet band. All right, so what is general principle in dilution? Number of moles of the solute is not changing. Based on that, if I make that assumption, the number of moles of solute is not changing, I can calculate number of moles before and after dilution. So is it fair to say that number of moles of the solute is equal before and after dilution? And what do we know about number of moles of solute? Do you remember molarity was defined as number of moles divided by volume? So if I want to solve this equation for number of moles, which is N, I can say 1 times N is equal molarity times volume. So can I say before dilution, I have initial molarity and initial volume. I am adding some water, so volume is changing to final volume. And molarity is changed because the solution has less concentration. So this is simply saying that number of moles before and after are equal together. So this is formula that I can use for dilution. All right, let's apply this principle to this problem. How do you make 60 ml of 0.2 mole per liter of nitric acid from stock solution of 4 molar nitric acid? So can I say these are information about final solution? In other words, can I say I want to make 60 ml? That is V final. And I want to make a solution of concentration of 0.200 mole per liter. So can I say this is final molarity? And then the question is, the solution that we are using to make this diluted solution is 4 mole per liter. So can I say 4.00 mole per liter is my initial molarity. That's what I start with. And how much of this, how much volume do I need to have 60 ml of 0.200 m? So can I say, based on the principle that initial volume times initial molarity is equal to final volume times final molarity. And in this, I have final molarity, I have final volume, I have initial molarity. So all problem is asking me is determine the amount of VI. How much of 4 molar nitric acid do you need to make this solution? Can I say I can solve this equation? It's one equation and one unknown. So all I need to do to look at VI. So can I divide both sides by MI? And I say, on the top, I have final volume times final molarity divided by initial molarity. That gives you the volume of the 4 molar nitric acid that you need to make 60 ml of 0.2 molar. So all I have to do, plug in molarity, final molarity of the solution, final volume divided by initial molarity. Does this make sense? So let's try to do it. Let me clean up my board. Now that you understand the logic of solving this problem, I can clean up my board and I can show these steps one step at a time. Number one, final molarity times final volume is equal to initial molarity times initial volume. So initial molarity, 4 mol per liter. Final molarity is supposed to be 0.2 m. Final volume, it's supposed to be 60 milliliter. Guys, if I'm going to convert 60 milliliter to liter, is it fair to say all I have to do divided by 1,000? So instead of 60 ml, I can write 0.06 liter. And problem is asking, what is the original volume from concentrated acid? I have to solve this equation for VI, and as we did, VI is equal to MF times VF over MI. So now, all I have to do, plug in the numbers given by the problem. Final molarity, is it 0.2 molar? Final volume, is it 0.06 liter? Excuse me. Divided by initial molarity. Problem said the acid that you have to start with is 4 molar. So I write 4 molar here. So by doing this, excuse me, you get the volume 0.003 liter. And if I want to express this in milliliter, all I have to do multiply liter by 1,000 to get milliliter. So, or you can say, for multiplying by 1,000, I'm going to move decimal point 3 times to the right. I hope this makes sense to you. If it doesn't, please make sure to come and see me so I can discuss it with you on Zoom. So how do you do this in the lab? Well, you're going to get 57 ml of water, and to this, you're adding 3 ml of the acid. The result is a total of 60 ml of solution, which has a concentration of 0.200 mol per liter.